and welcome. And in this video, we're going to talk about multiplying matrices. Okay, so multiplying matrices. This is just kind of continuation of us working with matrices. Okay, so make sure that you watch the video on talking about how to identify what the dimensions of a matrix are, and probably adding and subtracting wouldn't be a bad idea to check out as well. But let's get into multiplying matrices now. Just so you know, just like with adding and subtracting, you can't multiply any two matrices together. There has to be a relationship with the dimensions of each matrix. Now, with adding and subtracting, remember that the dimensions actually had to be the same. In order to add or subtract two matrices together, the dimensions of each matrix had to be the same. That is not the case with multiplying, okay? And it's actually it's gonna sound a little weird, and it is a little weird at first, but once you see us actually multiplying them together, you'll see why this is the case. Now, in order to multiply two matrices together, the number of columns of the first matrix must match the number of rows in the second matrix, okay? Now that seems super weird, I get it, okay? But you'll see why. So for example, and order matters, okay? So for example, if I wanted to do A times B, okay? This doesn't work. So A times B, when I say order matters, what I'm saying by that is A times B is actually going to be different than B times A. The commutative property does not work that way. Okay, now when we normally multiply numbers together, like 2 times 4 is the same as 4 times 2. It doesn't matter the order. But with matrices, it actually does, okay? So that's what I mean by order matters, okay? So the number of columns in the first matrix, A in this case, needs to match the number of rows in the second column, B, okay? So if I look at A, this is a 3 by 2, and if I look at B, that's a 2 by 2. Basically, a way to kind of figure out very quickly if you actually can multiply two matrices together is to see if the inner dimensions match, okay? What I mean by that is if I do 3 by 2 and 2 by 2, these are the dimensions of A and B. Notice these inner ones match. That actually means that I can multiply the matrices together, okay? Because this is the number of columns in the first matrix, and this is the number of rows in the second matrix, okay? So they are going to end up being able to be multiplied, all right? Super weird right now, I get it, okay? And the way we multiply them is going to be a little weird. Totally giving you a warning, all right? Now, the way that we multiply matrices, once we establish that we actually can multiply them, is we multiply each row in the first matrix by each column in the second matrix. Sounds confusing. I promise it's really not that bad. And I color coordinate it just to help out, okay? So what I mean by this, so we're going to take the first row and we're going to multiply each of the two columns by this row, okay? So let me get set up. What I mean by this is I'm going to take this number 3 in the first row and I'm going to multiply it by the first entry in the first row of the second matrix. So 3 is going to multiply -1, okay? And what I do with that is I actually add that to -2 times +2. So this seems really weird. I totally get it, okay? But promise, it just takes a little bit of practice and you're going to understand it. So 3 multiplied -1 and -2 multiplied +2, okay? So the first row multiplied the first column, okay? And whatever this ends up spitting out is going to be that entry at position 1, 1, okay? First row, first column. So if I went ahead and actually simplified this, this would be -3 minus 4. So the first entry is actually going to be -7, okay? Super weird, I know, but just stay with me, all right? Now for the next entry. So we did first row, first column. We did first row, first column. That got me the entry in the first row, first column. Now I got to do first row, second column, and that's going to, lo and behold, get me the entry for the first row and second column, okay? So I'm going to do 3 times 6. 3 times 6, okay? So 3 and 6, and now I'm going to add that to -2 times 0 plus -2 times 0. Okay, and what that would get me is 18 plus 0, which is 18. So notice that entry there would be 18. So I'm taking the first row and I'm multiplying it by the second column, and that gets me the entry to the first row, second column, okay? And notice I'm adding those together. It's the sum of the products. I know that sounds weird. But now we would move down the line, okay? So now I used up the first row from the first matrix. I used that up. So now what I gotta do is I gotta move down to the second row. And I'm just gonna repeat this process. So now I'm gonna do 4 times -1 plus 1 times 2. And then I'll move on and so on and so on. So now it's gonna be 4 times -1, 4 times -1, plus 1 times 1 times 2. 1 times 2, okay? And that would end up getting me -4 plus 2, which is -2, all right? Hopefully you're with me still. And then we move on. So that was the second row, first column. Notice it got me the entry second row, first column. And now I do second row, second column. So now it's going to be 4 times 6. So 4 times 6 plus 1 times 0. Okay, and that would end up getting me 24 plus 0, which is 24. So there is my second row. Okay, there is my second row. And now I used up the first row, I used up the second row, now I'm gonna move on to the third row, and I'm just gonna repeat this process. So it says -3 times -1, so -3 times -1 plus 5 times 2. So 5 times 2. And what that would end up getting us is 3 plus 10, which is 13, okay? And then finally, we're almost done. We'd have -3 times 6 plus 5 times 0. Let me go ahead and do that. So -3 times 6 plus 5 times 0. Okay, 5 times 0, which would get me -18 plus 0, which is -18. So what that tells me is that matrix AB would end up being -7, 18, -2, 24, and 13, -18. And there is our solution, okay, guys? So notice here how the inner dimensions match. That meant I could actually multiply them together. We'll take a look at what the final product's dimensions are. These dimensions are 3 by 2. And if you notice, the outer dimensions were 3 by 2. So the outer dimensions actually are going to tell you what the final answer's dimensions are going to be. So that's just kind of a neat trick to be able to see if you're actually able to multiply the two matrices together, and also what the final product's dimensions are going to be, okay? So I want to cover another example, but before I get to another example, I want to show you guys something real quick. Earlier I said A times B is not the same as B times A, right? I said that order does matter. That 2 times 4 is equal to 4 times 2, but that doesn't apply with matrices. Here's why. Say I wanted to do B times A. Well, I would double check to see if it works, right? Well, the dimensions of B, that's 2 by 2, and the dimensions of A, 3 by 2. Notice that these two dimensions do not match up, so you actually would not be able to multiply these together. Since the number of columns in this first matrix, which in this case is B, did not equal the number of rows in the second matrix, which in this case was A, we would actually not be able to multiply these together, so that would be not defined, okay? You could go ahead and try to use this pattern to multiply these two matrices together. I'm telling you right now, it doesn't work because you're not able to multiply those two matrices together. It is undefined, okay? So that is just to go ahead and show and kind of prove to you guys that A times B is not the same as B times A when it comes to matrices, all right? Let's go ahead. I want to take a look at one more example because I know this is a little bit confusing. It's a little bit weird. I want to get you guys exposed to some more problems. So let's go ahead and take a look at another problem. Okay, so I have two new matrices here. I have C and D, okay? So let's go ahead and figure out C, D. Okay, let's figure out CD. So C times D. All right, well, let's make sure that we can actually multiply these two together first. So let's see if the dimensions end up matching. They don't have to match perfectly. Remember what I mean, the inner dimensions, okay? So C is a 2 by 1, right? C is a 2 by 1, 2 rows, 1 column. And D is a 4 row by 2 column, okay? So notice, since these do not match up, I actually cannot multiply C to D, okay? C times D does not exist. It is not defined, okay? So unfortunate, but let's go ahead and see it the other way. Let's see if D times C would end up working out, okay? This one actually is going to work out because D, as we just established, is a 4 by 2, and C is a 2 by 1, so these inner dimensions match, so they can be multiplied. And remember, the outer dimensions are actually going to help us figure out what the dimensions of the final answer are going to be. Our final answer is going to be a 4 by 1, okay? So 4 rows, and only 1 column. So let's see what that looks like. Well, let's go ahead and do this. D times C. So we got to be careful with the order, okay? So now we're doing the rows of D and the single column of C, okay? So what this is going to look like, this is going to look like 1 times 3. So 1 times 3 plus, okay, 0 times 7. Okay, so 1 multiplies 3, 0 multiplies 7. And that's going to be the first row, first column. Because remember, this is just going to be a 4 by 1, 4 rows with only 1 column. Now I used up that row and all the columns in C, so now I move on to the next row. So then the next row is going to be 3 times 3. So 3 times 3 plus negative 2 times 7, okay? So we had 3 times 3 and negative 2 times 7. And then we continue. Now we're moving on to the next row. And this would be 0 times 3, 0 times 3, plus 1 times 7. Okay. 0 multiplied 1, or excuse me. 0 multiplied 3, 1 multiplied 7, and then I move on to the last row. 6 is going to multiply 3, negative 1 is going to multiply 7. Okay, so I got 6 times 3, 6 times 3, and negative 1 times 7. Okay. All right, and this is going to get me my 4 by 1 matrix, okay? So D times C, remember C times D did not exist, but D times C will exist, and that final answer is going to be, well, that would be 3 plus 0, which is 3. That's our first row, first column. 9 minus 14, that's going to end up coming out to be, you could do plus negative 2 times 7. I just did minus 2 times 7, same thing, okay? Don't freak out. So that was what, 9 minus 14, so that's a negative 5, okay? Then this is going to be 0 plus 7. So 7, and 18 minus 7, so 11. And that is going to end up being our final answer, okay? I hope this was helpful. If you have questions, please feel free to let me know. I'll probably make another video for multiplying just because adding, subtracting, pretty straightforward, but multiplying can be a little bit confusing, okay? So I will make another video with just another couple examples. Feel free to check that out. But as I said, if you have any questions, make sure you let me know, and I look forward to seeing you guys in the next video.